We would like to welcome you to the Odra Health Care Channel. If you have been looking for information on how to increase brown adipose tissue naturally, we have our top 3 compilation videos that we have researched and want to present to you. Also, we have provided the information to their different YouTube channels. Make sure that you visit them. Please don't copyright strike us. This is to inform, educate, and entertain our audience. But first off, there are links at the bottom in the description of this video that will take you to the official page that you see here. If you are looking for some fantastic information on a weight loss supplement that is also said to target your brown fat, or what is called low brown adipose tissue, BAT. Note, as it says here, that this is said to be the real root cause of your belly fat and not diet or exercise, as you can see it says here. The featured official website or supplement is called Exapure, Weight Loss Supplement. Also, as you can see here as well, this featured supplement is said to be GMP certified. This is also said to be made in an FDA-registered facility. Made with natural ingredients. Manufactured in the USA as well. Also, the featured supplement is said to be GMO-free, as you can see here as we scroll. Now pay particular attention to here, where it shows the ingredients that this featured supplement is said to contain: perilla, kudzu, holy basil, white Korean ginseng, amur cork bark as well, propolis, quercetin, and oleuropein as well. There is much more information for you to see once you get to the official page as well. So, if you want to look more into the featured website to see the supplement for yourself, all that you have to do is just click on the links provided in this description to see more on the featured Exapure weight loss supplement. But now, let's get to our selection of videos that we have researched for how to increase brown adipose tissue naturally. We hope that you will enjoy it. Where we researched the videos from. Video number 1 is from the Stanford Medicine YouTube channel. Video number 2 is from the Andrew Kwong YouTube channel. Video number 3 is from the Health Ally YouTube channel.
All right, while we're switching computers here, I'd like to introduce Ed Engelman, Professor of Pathology and Medicine, Immunology and Rheumatology, Director of the Stanford Blood Center, which is one of the only university-based blood centers in the country. And this comes with a great story about Ed initiating the testing of blood donations for HIV at a time 30 years ago when this was considered a great and unnecessary imposition. And it's pretty obvious now how that story turned out. He may actually be better known for his work on the first vaccine to be approved by the FDA for the treatment of cancer just last year. And most recently, his lab has published 2 very high-profile studies in Nature Medicine, linking immunity, insulin resistance, obesity, and type 2 diabetes, which seems like a great follow-up to Gary's talk, yes? Thanks, Ed. I think this is working though? It had a pointer, but it wasn't working. Do you need a pointer?
I don't know. Probably not. Great. I have 30 minutes, right? Just kidding. Just kidding. Christopher has been working so hard to organize this event and admonishing us to make sure we stay within our time limit. So I shouldn't have said that. Give him a heart attack. Yes, yes. Well, as Christopher mentioned, I'm actually an immunologist and really had no knowledge or business in the field of which we're discussing today, Jerry's field. But a new postdoc of mine who came to the lab just a few years ago raised a crazy idea, which is it possible that the immune system plays a really important role in the diabetes that develops in association with obesity? And I don't have to tell this group that obesity is a big problem. That's funny, I'm being the first speaker to sort of mention it, but our focus has been on the disease associations with it, in particular insulin resistance and type 2 diabetes. As I think most of you know, 25% of people over the age of 60 are obese and develop diabetes. So there's a remarkable association between these 2 disorders. And historically, there has been no real thought that type 2 diabetes is an immunological disease or even an inflammatory disease. Type 1 diabetes, by contrast, of course, is a classic autoimmune disease where the insulin-producing cells are attacked and destroyed by host T cells. Our recent studies suggest that the adaptive immune system, those elements of the immune system that can recognize elements with specificity, play a significant role in the development of this disease. Now, most of our studies have been done in laboratory animal models, particularly fat mice, but not all. And I know Jerry will remind me that most of these studies have been done in mice and not people, and I think that's a fair point. But it's really easy to make mice fat. You just give them a high-calorie, high-fat diet, and those animals invariably develop insulin resistance and go on to become diabetic, basically indistinguishable from people. So that's what we started doing. We took C57 black mice, which is a normal mouse strain, gave them a high-fat, high-calorie diet, and started studying their adipose tissue. And what we discovered is that in their adipose tissue, in the deep adipose tissue or visceral fat, more so than the subcutaneous fat, we found changes. We found massive infiltrates of inflammatory adaptive immune cells, particularly T cells. And I don't have the time today to demonstrate all the data, but I will simply point out that one particular subset of T cells called T regulatory cells, which down-regulate the immune response, are present in much lower proportions in the visceral fat of these obese mice than they are in normal mice. And in fact, other cells, particularly inflammatory T cells, Th1 cells and Th17 cells, which produce potent inflammatory cytokines, are present in much higher proportions than they are in normal animals. So about 3 years ago, we started experiments based on the hypothesis that the inflammatory T cells were bad, and what would happen if we gave an antibody that would eliminate these cells, or at least eliminate some of them. And the classic antibody that is used, we use for these studies, is a broad-based anti-CD3 antibody that affects all T cells and generally eliminates more of the inflammatory T cells than the Treg cells. And that's what we did. So we took these animals, gave them a few injections of this antibody over a period of a few days, and then observed them over a period of several months. And what we found is that the proportion of regulatory T cells, I don't have a pointer that works, so I will just point with my finger. After anti-CD3 treatment, you'll see in the vat, in the visceral fat, goes from about 8% to about 17.7%. And none of the controls showed any problems, so we were able to reconstitute the normal ratio of T cell subsets after this antibody treatment. And the most striking finding is that glucose, the abnormalities of glucose metabolism completely normalized in these animals. And this was part of the basis for our first paper in Nature Medicine, which was published in 2009, which documented that the adaptive immune arm, particularly T cells, played a critical role in development. And as I said, it's remarkable that essentially a single course of treatment with this antibody normalized the glucose metabolism of these animals for as long as we observed the animals thereafter. Not to exclude human beings from our studies, we did have access at that time to biopsies of fat from individuals undergoing various types of surgery, and we were able to document that the body mass index was a very nice predictor of the ratio of Th1 cells to Treg cells. So T-bet is a marker of Th1 cells, and FOXP3 is a marker of the Treg cells. We did immunohistochemistry staining, very simple, straightforward, simply counted the various populations, and were able to confirm that the same changes in these subsets that occur in our fat mice also occurred in obese individuals in proportion to their obesity. So just to summarize very briefly, the T cell role in this in glucose metabolism, what our findings indicate, and others have now added to these findings and confirmed them and extended them, is that certain subsets of T cells, notably the Treg cells and the Th2 cells, which are immunomodulatory cells, tend to downmodulate inflammation And under normal circumstances, at least in lean individuals, they cause macrophages to remain quiescent. These macrophages produce IL-10, which keeps the inflammation away and maintains a normal status. Under obese conditions, there is an invasion, an infiltration of inflammatory T cells, particularly Th1, Th17, CD8 effector cells, that overwhelms the regulatory cells, causing these macrophages to become inflammatory, and we believe that is the essence of the inflammation that ultimately causes and exacerbates insulin resistance. Now, well, let me just say that at that point, we knew that T cells were very important. We then asked the questions, what about the other very important adaptive immune cell, the B cell, the cells that produces antibody, that can also produce cytokines, that can also be an antigen-presenting cell and stimulate T cells? And what we discovered in other sets of mice where we were able to knock out various types of cells and other things is that, in fact, B cells also play a very important role. So let me just show you here that if we administer to obese animals, rendered obese by a high-fat, high-calorie diet, a broad anti-B cell antibody, in this case anti-CD20, in order to eliminate all the B cells, we find that the effect we see is similar to what we saw with our broad anti-T cell antibody, namely a normalization of glucose metabolism, a reduction in inflammatory mediators, and really a remarkable and surprising observation. In addition to that, we looked into the mechanisms by which these B cells are causing problems, and one very important mechanism is their production of autoantibodies, because we could transfer the disease, we could transfer the abnormal glucose metabolism by taking IgG from obese insulin-resistant animals, concentrating the total IgG and transferring it to young lean animals that had started a high-fat diet, and we could essentially reproduce the abnormal insulin and glucose metabolism. So that is one mechanism by which B cells can induce or exacerbate disease. This is a simple summary, not so simple to you, I'm sure, but simple to, in that, analogous to the T cell summary, in that what B cells can do, they can make antibodies. We believe that these antibodies are to specific inciting antigens, but that the one role that these antibodies have is to attach to the Fc component of macrophages and cause those macrophages to become inflammatory. We know that B cells are also presenting antigens to T cells, the same T cells that were driving the inflammation in the visceral fat. So we believe that B cells and T cells are working together to make this disease worse. And this is a brief summary of this work. So the last piece on B cells was published in Nature Medicine about 3 or 4 months ago. And to summarize what our current state of knowledge is with regard to the role of the immune system, we know that in lean, healthy individuals, insulin sensitivity is regulated by good T lymphocytes, if you will, the cells that down-modulate the immune response. Under conditions of high-fat diet, there is an inflammatory reaction that occurs in adipose tissue, particularly the visceral fat, with increased frequency and activation of inflammatory T cells, Th1, Th17, CD8 cells, B cells, and type 1 macrophages. Those are the macrophages that put out pro-inflammatory cytokines that overwhelms the normal down-modulating activities of the other T cell subsets. B cells contribute to the disease by activating pro-inflammatory T cells and macrophages and producing autoantibodies. What I didn't show you today was that in the paper that we published just a few months ago, we were able to demonstrate that with the help of Tracy McLaughlin, that in individuals who are otherwise healthy but insulin resistant, in a small cohort of men with such characteristics, they had in their circulation autoantibodies that were distinct from anything that was in the insulin, in otherwise BMI-matched insulin-sensitive individuals. So we believe we've identified, at least in a preliminary way, an autoantibody profile that may ultimately predict the development of type 2 diabetes associated with obesity. Remarkably, both the T cell and B cell mediated effects are reversible, as we demonstrated with antibodies to the cells, at least during the development of disease. So that's our story. I want to point out that this last several years has been a collaboration between people here at Stanford and people at the University of Toronto, two identical twin postdocs, Dan Weiner and Sean Weiner, were really played critical roles in the development of the hypothesis. Lei Shen in my lab and Dan have worked very closely on all of this work. And our principal collaborator here at Stanford is Tracy McLaughlin, but there are many others that have contributed to this work. And with that, I will also point out that we work over at the Stanford Blood Center, which Christopher kindly described a few miles from here, but it's a very happy place. See, all these people are smiling because they're so happy. All right, thank you.
The preceding program is copyrighted by the Board of Trustees of the Leland Stanford Junior University. Please visit us at med.stanford.edu.
In this video, I will share with you how you can lose fat simply by taking cold showers or exposing yourself to colder temperatures. But it is not a fat loss method that you can rely on solely to lose a ton of weight. Cold exposure therapy has been recently popularized by Wim Hof using his Wim Hof method, which is a method of achieving greater happiness, health, and self-improvement using cold therapy and breathing techniques. Wim Hof can withstand freezing temperatures, climbing Mount Everest with only shoes and shorts. It's quite amazing. Before we get into the scientific research of cold therapy, let's look back at how humans evolved. If you look back at our ancestors, they have evolved to live in extremely harsh conditions, from hot grasslands to cold tundras. What this means is our human bodies have developed mechanisms to adapt to extremes of hot and cold. When exposed to cold temperatures, our body responds with a variety of adaptive changes, a process called hormesis, boosting metabolism and providing many other health benefits. In one study, 8 men were immersed up to their necks in cold water of various temperatures, 32 degrees Celsius, 20 degrees Celsius, and 14 degrees Celsius for 1 hour. Under the cold conditions, the young men's resting metabolism increased by 93% in the 20 degree or 60 degree Fahrenheit water and 350% in the 14 degree Celsius water. Under warm conditions though, no metabolic changes were observed. So how does our body boost metabolism in response to cold? If you stay in the cold long enough, eventually your body will automatically start to shiver in order to generate heat, boosting your metabolism, a process called shivering thermogenesis. Another method your body uses to combat the cold is non-shivering thermogenesis, which is the key adaptive mechanism that we are interested in for fat loss. In this process, a metabolically active type of fat in our body called brown fat gets activated and generates heat. Thus, the more brown fat you have, the more likely you will withstand colder temperatures, and the more leaner you will likely be. In one study, it was found that overweight and obese men had lower brown fat adipose tissue activity. Brown fats contain large amounts of special mitochondria that house a protein called uncoupling protein 1, UCP1, which combusts fatty acids into energy in the form of heat. Newborns and many animals naturally have a lot of brown fat, but as we grow up, the brown fat transforms into white adipose tissue or white fat, leaving a very small amount, usually around the neck or the shoulder area. The awesome news is that it is possible to convert our regular white fat into brown fat by simply exposing your body to cold temperatures more often. Let's look at the scientific studies that shows an increase in brown fat and thermogenesis through cold temperature exposures. In one 2013 study, 8 men and 9 women were exposed to cold temperatures of 15 to 16 degrees for 6 hours a day for 10 days. What they found was both men and women increased resting energy expenditure of an average of 12% and 11% respectively. These men and women also showed significant increases in non-shivering thermogenesis after the 10-day cold exposure period, from 11% to 18% of their total daily expenditure, meaning that their bodies become more efficient in converting fatty acids to heat energy in response to cold after that 10-day exposure. The most interesting finding from this study was that the amount of brown fat tissue was observed in the 17 subjects to increase by 37%. In a May 2018 study by Acosta et al., 11 young lean men wore cooling vests with a starting temperature of 16.6 degrees Celsius. The temperature dropped by 1.4 degrees every 10 minutes until participants shivered. And what they found was that the resting energy expenditure increased by 31.7% when they reached the shivering state, and an increase in fat oxidation by 72.6%, whereas carbohydrate oxidation remained unchanged. What this means is that when brown fat is activated, the additional energy expended are mainly fatty acids, which is what we want to burn. Many other studies show similar results in terms of brown fat and energy expenditure increase. So you might ask, how do we apply this to our daily routine to maximize fat loss? Ideally, we would expose our bodies to the coldest temperature possible for the longest length of time that we can withstand somewhat comfortably to maximize thermogenesis. Some techniques I used that anyone can easily apply in their daily routines are: take cold showers for 5 to 10 minutes, the colder the better. At first, it'll be uncomfortable, but you can slowly start to adapt by decreasing the water temperature slightly every time you shower until you reach the coldest temperature. The second thing is lower your temperature in your home to 15 to 16 degrees Celsius, or to a low enough temperature that you are comfortable with. The third one is thin layers of clothing, and avoid wearing jackets unless you absolutely need it. Fourth is drink cold water. Two other things that I thought that would also help are going swimming in a cold pool, taking ice cold baths. I must warn you though, that there is a chance that you might unconsciously eat more because of this metabolism boost, as shown in one rat study. Exposing mice to 4 degrees Celsius air for 1 to 8 hours 3 times per week increased their metabolism and improved their blood sugar response. However, the mice ate so much to compensate for their higher energy expenditure that they didn't lose any weight. So even if you apply this cold therapy method, you won't lose fat if you eat more to compensate for the extra energy expended. In addition to increased thermogenesis and increased brown fat, other health scientifically proven benefits of cold exposure include fighting inflammation, increased lifespan, strengthening the nervous system, injury healing and increased recovery speed, blood sugar level regulation, improvements in sleep quality, strengthening of the immune system. So the takeaway is that cold temperature exposure increases non-shivering thermogenesis and increases the conversion of white fat to brown fat, which in turn leads to greater efficiency in fat oxidation to produce heat energy. It also promotes many other health benefits. And to sum up, to take advantage of this cold therapy for fat loss, take cold showers, lower your household temperature, wear less clothing, drink cold water, go swimming in a cold pool, take ice cold baths. And that's the end of my video. Thank you so much for watching, guys. If you found this video helpful, please like, share, and subscribe to my channel, as well as turn on notifications for my channel. I would really appreciate it. Let me know how this method is working out for you by leaving your comments below. Again, thanks for watching, guys. I'll see you in my next video.
Transform your life with the help of brown fat. Brown fat, also known as brown adipose tissue, is a type of body fat that responds to cold temperatures. Brown fat produces heat, which aids in maintaining a stable body temperature in cold weather. Brown fat contains significantly more mitochondria than white fat. Fat provides energy to your body, protects your organs, promotes cell growth, regulates cholesterol and blood pressure, and aids in the absorption of essential nutrients. When you focus too much on eliminating all fat, you may deprive your body of what it requires the most. Large droplets of lipids, also known as fatty acids, are found in white fat cells. Brown fat is made up of tightly packed mitochondria that are high in iron and thus appear brown. Mitochondria in brown fat cells use sugar to produce energy, whereas white fat cells store more energy and take up more space. Exposing your body to cool, even cold, temperatures may aid in the recruitment of more brown fat cells. According to some studies, just 2 hours of daily exposure to temperatures around 19 degrees Celsius may be enough to turn recruital fat brown. Consider taking a cold shower or an ice bath. Resveratrol, a polyphenol compound found in red wine, some herbal ingredients such as oregano, thyme, capsaicin, the spicy component of hot peppers, can help stimulate the growth of brown fat cells as well. Scientific reports noted that caffeine in coffee is another way to help induce browning features in adipose tissue. Norepinephrine, the hormone that keeps your body warm, is produced by brown fat. Brown fat contains norepinephrine receptors. When these receptors detect the hormone, they signal many mitochondria to begin producing energy, which produces warmth and aids in body temperature regulation, thus beginning the thermogenic effect and burning calories. 9 ways to get your body's brown fat to help you lose weight faster. The foods that activate this fat listed below are also healthy and nutrient-dense. Aside from eating certain foods, there are several other ways to activate your body's brown fat and lose weight faster. According to University of Iowa research, the skins of these fruits are high in arsenic acid, a compound that helps revitalize tired, aging brown fat so that it behaves as if it were energetic and young. If you eat 1 apple or pear per day, you could lose 2 pounds of body fat each month without dieting. L-arginine, an amino acid that activates this type of fat, is abundant in turkey breast. According to British research, eating 4 ounces daily could help you lose 5 pounds in 2 months. L-arginine is also abundant in peanuts. Shivering in a 58-degree house prompts this fat to convert twice as many calories as usual into heat. Is it too cold? Instead, eat 1/2 teaspoon cayenne powder or a few jalapeno slices every day. The active ingredient in peppers, capsaicin, energizes the fat in the same way that shivering does. A Swiss study found that drinking 3 12-ounce mugs of green tea daily increased brown fat burning by 5%. Green tea's antioxidants aid this fat in absorbing one of its preferred fuel sources, glucose. Green tea should be purchased in bags rather than loose leaves. According to the researchers, the finely ground tea in the bags makes it easier for the antioxidants to dissolve in water and be absorbed by your body. Apple skins are high in arsenic acid, a natural compound that helps build and strengthen muscle tissue while also stimulating the formation of new brown fat, according to new research. Taking 1 milligram of melatonin 30 minutes before lights out can prompt your brown fat to torch up to 36% more calories overnight. Melatonin ensures your fat stays active even when you're in dreamland. Fitting in 30 minutes of physical activity daily increases your calorie burn, as much as 20% in 10 days, doubling your ability to slim down without a struggle. When you exercise, your muscles release an enzyme that actually turns bits of white fat into slimming, calorie-hungry brown fat. Simply carving out a little time each day from your hectic schedule to unwind could boost your brown fat calorie burn in as little as 2 weeks. How so? By tamping down your body's production of cortisol, a stress hormone that makes brown fat sluggish, according to researchers. Tip: a gentle 10-minute do-it-yourself foot rub at bedtime can cut your cortisol levels by 25% or more. Feeling chilly for 20 minutes daily can fire up your brown fat's calorie burn in as little as 24 hours, say British researchers. What's more, the more often you're exposed to bursts of cold, the more efficient your brown fat becomes at incinerating food to produce heat. To do: take cooler showers and baths, Wear lighter layers outdoors and keep the temperature in your home and car on the low side. Finally, once the brown fat you were born with is performing optimally, your body responds by converting flabby white fat into this slimming calorie burner, according to a Swedish study. Creating just 2 ounces of active brown fat could increase your calorie burn by 20%. Thank you for watching. Please like, share and subscribe to our social media platforms.
Now, once again we would like to thank you for watching our top 3 videos for how to increase brown adipose tissue naturally. Hit that like button and that subscribe button if you enjoyed this video. Also remember that we have links below in the video description that will take you to the official page that you see here, for some fantastic information on a weight loss supplement that is also said to target your brown fat, or what is called low brown adipose tissue, BAT. Note, as it says here, that this is said to be the real root cause of your belly fat and not diet or exercise, as you can see it says here. The featured official website or supplement is called Exapure, Weight Loss Supplement. Also, as you can see here as well, this featured supplement is said to be GMP certified. This is also said to be made in an FDA-registered facility. Made with natural ingredients. Manufactured in the USA as well. Also, the featured supplement is said to be GMO-free, as you can see here as we scroll. Now pay particular attention to here, where it shows the ingredients that this featured supplement is said to contain: perilla, kudzu, holy basil, white Korean ginseng, amur cork bark as well, propolis, quercetin and oleuropein as well. There is much more information for you to see once you get to the official page as well. So, if you want to look more into the featured website to see the featured supplement for yourself, all that you have to do is just click on the links provided in this description to see more on the featured Exapure weight loss supplement.